This is Math 6, Lesson 2-1, Finding the Mean. Mean is the sum of all the data divided by the number of data points. Sometimes this is referred to as average. So if you ever hear the average of something, it's the same thing as saying the mean. An outlier is a data item that is much greater or much less than all of the other data items. Today, we're going to look at computing the mean in two different ways. The first way we're going to learn to compute the mean is to use a model. As you can see here, we have different colored dots representing the numbers that are listed. So if we're going to try to find a model to find the mean of 3, 6, 3, 4, 2, and 6, I have 3 white circles, I have 6 blue circles, I have 3 red circles, 4 green circles, 2 pink circles, and 6 orange circles. I want to try to make these equal because that's what the mean is. The mean is the average. So to make these equal, I will move some of my colored dots to fill in some blank spaces. So I could take this blue dot right here and I can move it over here. And then I can realize that each one of these I can move this blue dot here, and maybe I can move one of my orange dots here, and then one of my other orange dots here, and now I have groups of 4. I have 1, 2, 3, 4, 5, 6 groups of 4. So the mean here has to be 4, because that's what I have my equal groups as. So the mean is 4. That's how you can use models to try to find the mean. Models are great visual representations. However, I don't happen to carry a lot of different colored discs or circles around with me, so sometimes it's difficult to use models to compute the mean. So another way to compute the mean is to do it mathematically. Mathematically, we will add all of the data points up and then divide by the number of data points that we have. For example, let's say you play a word game. Your scores are 12, 23, 13, 32, and 20. If you want to find your mean scores, the first thing you must do is add up all of your scores. So I had 12, I had 23, I had 13, 32, and 20, and I'm going to add these up. 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. Carry my 1. 2, 3, 4, 5, plus 3 is 8, plus 2 more is 10. So if I add all this up, I get 100. I have 1, 2, 3, 4, 5 data points. So I'm going to take my 100 and I'm going to divide it by those 5 data points. You always take your total and divide it by the number of data items that you have. 5 goes into 10 2 times. 2 times 5 is 10. With 0, bring down my 0. 5 does not divide into 0. So 20 is times 5 is 100. So my mean score here is 20. So to compute your mean mathematically, you add up all of your data points and then divide by the number of data points that you had. Let's try one more problem using mean. You have the following test scores: 78, 85, 94, 88, and 91. But you want to know, what's my overall grade? Well, your overall grade will be based upon the mean of your test scores. So you need to take all of your test scores and then divide them by the number of test scores that you have. So we have 78, 85, 94, 88, and 91. And I'm going to add these up. All right, let's see here. 5 and 4 is 9, plus 1 is 10. 8 and 8 is 16. 16 and 10 is 26. So carry my 2, put down my 6. 8 and 2 is 10. 9 and 9 is 18. 18 plus 10 is 28. 28 plus 8 is 36. 36 plus 7 is 43. So I have 436. I have 1, 2, 3, 4, 5 data points. So I'm going to take my 436 and divide it by my number 5, because that's the number of data points that I have. 5 does not divide into 4, but 5 does divide into 43. 8 times 5 is 40. 43 minus 40 is 3. Bring down my 6. 5 divides into 36 7 times, because 7 times 5 is 35. 36 minus 35 is 1. I can't divide because I don't have any more numbers until I put a decimal point and annex a 0. I put a decimal down there, so it means I need to bring my decimal point straight up, bring my 0 down here, and 5 goes into 10 2 times. 2 times 5 is 10. I now have a 0 remainder, so my mean here is 87.2. So if this was your test scores, your mean would be an 87.2, which is a nice, solid B, almost B+. This is how you compute the mean, both using models and by mathematically figuring that out. Now, the next thing we're going to do is take a look at analyzing our mean. If I have some bowls, I have 5 bowls of raisins. In each one of these bowls, I have 21, 26, 72, 27, and 24. If we look at this data, most of the numbers are in the 20s, except for this one number right over here, 72. It's much larger than all of my other numbers. Because it is much larger, we call it the outlier. So our outlier here is 72. We're going to find the mean of all of the raisins that we have in all of our bowls. So I'm going to take all my numbers and I'm going to add them up again. 21 plus 26 plus 72 plus 27 plus 24. Here we go. 6 and 4 is 10, 17, 19, 20. Carry my 2. Let's see, 2, 4, 6, 8, 10 plus 7 is 17. Notice how I don't obliterate my numbers, so if I mess up, I can still read them. So my sum is 170. I have 1, 2, 3, 4, 5 data points, so I'm going to divide by 5. 5 goes into 17 3 times. 3 times 5 is 15. Bring down my 0. 5 goes into 20 4 times, because 5 times 4 is 20. So the mean number of raisins that I have in each bowl is 34. Well, I don't have 34 raisins in each bowl. In fact, none of the bowls have more than 34 raisins in them, except for the one bowl that has 72, which helps us to see that our outlier raised our mean quite a bit. If I would take the number 72 out and I was to recalculate the mean, I would have less raisins in my bowls. Okay, let's take a look at how this outlier affects our mean. Let's add our numbers up without our outlier. So we have 21, 26, 27, and 24. 6 and 4 is 10, 17, 18. 2, 4, 6, 8, 9. So I now have 98, and I'm going to divide 98 by 4 because I have one less data point because I took the outlier out. Okay, I'm going to add a 0 just in case I need it. 4 goes into 8 twice. 4 goes into 9 twice, I should say. 2 times 4 is 8. Bring down my 8. 4 goes into 18. Let's see here. 4 times. 4 times 4 is 16. So 2. Bring down my 0. Yep, I did need to annex that 0. 4 goes into 25 times. So without that outlier of 72, our mean is only 24.5. So if we were to evenly distribute our raisins, we'd have to put 24.5 raisins in each bowl so everybody would have the same number of raisins if you take the outlier out. So how does the outlier affect the mean? The outlier increases the value of the mean. Okay? The outlier increased the value of the mean, which makes sense. If you look at it and think about it, if my outlier is much larger than all of my other numbers, then it's going to make the mean get bigger. If my outlier is much smaller than all my other data points, it's going to make my mean get smaller. So if my outlier is much larger, my mean goes up. If my outlier is much smaller, my mean goes down. And that's what we mean by looking at something and analyzing how an outlier can affect your mean. Let's say you babysit, and you're going to keep track of the number of hours you babysit for 6 days. One day you babysit for 1¼ hours, the next day 1.5, 1.5, which is 1.5, 7.75, 1 3/4, 2, and then 5.5. What effect does the outlier have on the mean? Well, we can see that 5.5, or 5.5, is much larger than all of the other times. The greatest number before that was only 2 hours. So this 5.5 is going to increase my mean because it's much larger. This outlier of 5.5 is much larger than all of my other numbers. So it's going to make my mean have to go up. So what effect does my outlier have? It will increase my mean. And this is the end of lesson 2-1.